Machine language. Machine language is the lowest level language a computer understands. It is made only of zeros and ones. For example, instead of writing add two numbers, you would write a long binary code that directly tells the CPU what to do. It is extremely fast, but impossible for humans to read or write efficiently, so nobody programs in this directly anymore. Assembly language. Assembly language is one step above machine language. Instead of zeros and ones, it uses short words like MOV, add, or sub. But it is still very close to the hardware. Each instruction usually translates to one machine instruction. It is very fast and very powerful, but also hard to learn and different for each type of processor. Low-level languages. Low-level languages are languages that work very close to the hardware, like assembly. They give you full control over memory and the CPU, but they are difficult to write and easy to make mistakes in. They are mainly used in operating systems, drivers, and embedded systems. High-level languages. High-level languages are made for humans, not machines. They use English-like words and simple syntax. Examples are Python, Java, and C++. Instead of worrying about memory and CPU instructions, you just tell the computer what you want to do. These languages are slower than low-level ones, but much easier and safer to use. Compiled languages. Compiled languages are converted into machine code before you run them. For example, C and C++ programs are compiled into an executable file. Once compiled, the program runs very fast because the computer is directly executing machine code. The downside is that you must recompile the program every time you change the code. Interpreted languages. Interpreted languages are executed line by another program called an interpreter. Examples are Python and JavaScript. You don't need to compile them first, you just run the file. This makes development faster and easier, but the program usually runs slower than compiled programs. Procedural languages. Procedural languages are based on writing step-by-step instructions. The program is a list of procedures or functions that the computer follows in order. For example, C is a procedural language. Object-oriented languages. Object-oriented languages organize code using objects. An object is like a real-world thing that has properties and actions. For example, in a game, a car object can have speed and color, and actions like drive or brake. Languages like Java, C++, and Python use this style because it helps manage large and complex programs. Functional languages. Functional languages are based on math functions. They avoid changing data and instead focus on transforming data. Examples are Haskell and Lisp. Instead of telling the computer how to do something step by step, you tell it what the result should be, and the language figures it out. Statically typed languages. In statically typed languages, you must specify the type of data in advance. For example, you must say, "This is an integer," or "This is a string." C++, Java, and Go work like this. This helps catch errors early, before the program even runs. Dynamically typed languages. In dynamically typed languages, you don't need to specify types. The language figures it out while the program is running. Python and JavaScript work like this. This makes coding faster and easier, but sometimes errors only appear when the program is already running. Domain-specific languages. Domain-specific languages are made for one specific job. For example, SQL is made only for databases. HTML is made only for structuring web pages. You wouldn't build an operating system with them, but for their specific task, they are extremely good. Visual programming languages. Visual programming languages let you build programs using blocks instead of typing code. For example, Scratch is used to teach kids programming. It's easy to learn, but limited in power. Esoteric languages. Esoteric languages are made as jokes or experiments. For example, Brainfuck is a language that is extremely hard to read and write. These languages are not used in real software and are mostly for fun or challenges. Markup languages. Markup languages are not real programming languages because they don't contain logic. Examples are HTML and XML. They are used to structure and describe data, not to perform calculations or make decisions.